Hello, welcome to Advanced Algebra 2. Here we begin the third learning target. If you can count super carefully, you might notice that I skipped the second learning target. I didn't really care for it much. We've got a lot to do, and I think you'll like that this goes straight into concrete stuff that you can do instead of stuff you have to see, which happened a lot in the last unit. So we've got some introductory text, which is mostly me just introducing things, I suppose. Let's move on. First of all, we need to practice some squaring. This is just FOIL stuff. So here we begin with x plus 4 squared. So that's x plus 4 times x plus 4, because it's squared, right? So then moving on, if you FOIL it, you get x squared. You get yourself a 4x for the outside ones, 4x for the inside ones, and then 16 for the last terms. And that's all well and good, but notice that the 4x and the 4x can go together, and so you can end up with x squared plus 8x plus 16. Now, take a moment, please, and notice that this middle term of 8x is double the 4's, or rather, it's even the 4's if you add them together, because, well, yeah. That's going to be important later on. Okay, another example. Here we have negative 3 times x minus 2 squared. So first of all, it just means negative 3 times x minus 2 times x minus 2. Just a quick reminder that the negative 3 itself is not squared, just the binomial, the two-term little chunk there, x minus 2 is. All right, so then my recommendation is that you go ahead and spend your time foiling first. So you get x squared minus 2x, another minus 2x, and then a plus 4 on the end. Nothing terribly exciting. I would just recommend ignoring that negative 3 coefficient in front at first. Then go ahead and clean it up a little bit. So x squared minus 4x plus 4. Again, I might point out that this negative 4 here in the middle is double the minus 2's, or double the minus 2 in the original problem. That, again, will be a key thing moving forward. But we're not done yet. That negative 3 still has to happen. So go ahead and distribute the negative 3 in, so you get negative 3x squared plus 12x minus 12. All right, good times. Third example, again with the squaring. This time I made it y equals, and then 2 on the outside, x plus 4 squared. All right, so again, make it x plus 4 times x plus 4, showing that that's squared, but the 2 is not squared, it's just hanging out. Then I would FOIL it. This time I did it quickly. X squared, you got a 4x, you got a 4x, you got the 16. That 2 is just hanging out. I clean up those two 4's. Again, I'll notice, hey, look at here. That 8 is double the 4's. Double these 4's, or double that 4 at the beginning. Then, when you multiply the 2 in, you get 2x squared plus 16x plus 32. Nothing terribly exciting has happened here, folks. I'm sure you did lots of these problems in Algebra 1. It's worthy of review, absolutely. Let me know if you're having trouble with this specifically. However, and this is where it gets good, we're going to do this exact same thing backwards. So now we work backwards in order to change a quadratic function into vertex form. And I'll talk about vertex form later, but oh goodness gracious, here we go. Example 4. We've got this quadratic function because it's y equals x squared plus 6x minus 3. Good times. So first, here's what I'm thinking. That's x squared plus 6x plus something minus 3. Now, these missing somethings, they're always tricky to think about the first few times for everyone. But the point is that these things are going to be the same, and then I just need about 45 seconds of your patience to see what happens. It's kind of amazing. So here's what I'm thinking. You take that 6x, and And if you make it 9, those somethings, oops, got excited here, sorry. If you make those somethings into 9, then, well, check this out. You have x plus 3 squared. And then the minus 9 minus 3 turned into minus 12. Okay, that's way too confusing. Too many colors. Sorry. Let's try this again. Maybe different color here. This minus 3 turned into minus 12. Now, what was going on before was you take that 6 from the 6x, divide it by 2, 3, and then square that. That's the missing number. Take that 6, divide it by 2, square that. That is the missing number. You might remember I was pointing out some doubled up numbers before. So 6 was double of 3, and 3 squared is 9. Boom, you added an extra 9, so you had to take away that same 9. Otherwise, you'd lost the equation. And now here we have it. This is overwhelming at first for a lot of people. Maybe not for you. You might be too smart. But if for some reason it is overwhelming, don't get down. We got to move on though a little bit here. So we have, yay! Look at us, we did it. Okay, so here, boom. There's the equation that we just had. I just have screen issues that you don't have on your paper. So that was a lot at once. Sorry, folks. So that, and I'm writing the original thing. Okay, that plus 3 in the parentheses moves it left 3. The minus 12 at the end moves it down 12. So the vertex is at negative 3 comma negative 12. Because the parabola is moved left 3 and down 12. Or rather, the vertex is, boop, down there. Okay, the axis of symmetry, we should have talked about this in class on last class, is that vertical line that goes through the vertex. So it's the line x equals negative 3. Again, you should draw yours at the straight edge. It's kind of impossible to do that on an iPad screen for me. We have the y-intercept. Now the y-intercept is so easy, it's hard for a lot of people. You go back to the original thing, you plug in 0, and you get negative 3. So, boop. And then this extra point that helps us make a beautiful symmetric curve is called the symmetric point. It's at negative 6, negative 3 because, boop, it's over there on the other side of the line. So, you've got your vertex after completing the square, which was a lot. And then you've got the axis of symmetry that goes down through the vertex. The y-intercept, which is so easy, it's kind of hard for some people sometimes. And then the symmetric point over on the other side. Go ahead and draw yourself a nice, beautiful little curve there with arrows. You can probably do better on paper than I can on the iPad screen. And that's your parabola. All right, that's one example. We're going to do a couple more. Here we have y equals negative x squared plus 4x plus 5. Now, when you have a number in front of the x squared, the first thing you want to do is go ahead, well, first I just rewrote the problem. Then, to actually do something, the next thing you want to do is factor out that number, that coefficient in front. So, I factored out the negative, which is really negative 1. But I didn't mess with the constant term. I didn't mess with a 5, just from the terms that have x in it. So it's negative in front, x squared minus 4x. Now, okay, so now we're missing a term. So we should have a little blank line here. And then we have to take it away. But it's not just that number now. Now it's that number times negative 1. So that blue arrow is meant to show you where that negative 1 comes from. It is not actually distributing all the way over outside of the parentheses, because that would be crazy talk. So let's go back and look in the parentheses. We have a minus 4. So half of that is 2. When you square that, it makes 4. So x squared minus 4x plus 4. That's the magic. Which means then the missing number over there is also 4. So we got negative in front, and we got x minus 2 squared. And then the other stuff over when you're done is actually plus 9. So that is the equation after we've completed the square, which is that term for all this blank line drawing and filling in the magic numbers. Okay, now let's go back to the graph. First of all, we've got the equations. I just rewrote the original version of the equation, and then the one I was proud of, so I cloud circled it up. All right. In this case, we have a parabola that's been moved. Well, I wrote the word vertex first. Okay, here we are. It got moved right 2 and up 9. So the vertex is at 2, 9. So, boop. All right. Now, we have an axis of symmetry, which is that vertical line through the vertex. So the axis of symmetry is at the line x equals 2. All right. That's not really part of the graph, but it's the magic line that you could fold the parabola over. Okay. The y-intercept, again, so easy it's hard. It's at 0, 5. You just plug in 0. Boop. And then the symmetric point is same idea, but on the other side of the axis of symmetry. So it's going to be over at 4, 5. So ka-choom. And then connect them all up with arrows, with arrows. And I'll point out verbally here that this parabola is upside down, headed downstairs. You're probably not surprised, but that's because there's a negative number in front of the x squared, or even better, see, negative number in front of the x squared. No, that's, boop, there we go. Or even better, a negative number factored out when we complete the square. Of course, those two things would always be the same number, but that makes it upside down. Okay, one more example. Y equals 3x squared minus 9x plus 5. Okay. Last time it was negative x squared, so we factored out negative 1. This time it's 3x squared, so we need to factor out the 3. Again, I recommend you leave the constant term alone. It saves you agony and despair. Now, this is slightly less pleasant. You got to take half of 3, which is 1.5. Okay, so got the negative 3 over there for the makeup term because it affects the add-in term on the left in the parentheses. So it's like 1.5 squared, so 2.25. Oh well, okay. And a lot of people can't see this step on any of them, but they can actually see the next step easier, which is like, okay, it was 3, so it's going to be half, so it's minus 1.5 squared. And then over on the end, I just kind of collected all those constant terms together, and I want to be super duper clear about that. Again, here we had this, and we had this, and together they made the negative 2.75. All right, so that's all the hard grunt work with the algebra symbols. Now we play with graphs. So over here, I'm going to go ahead and write them down again. We got 3x squared minus 9x plus 5. We have 3 times the quantity, x minus 1.5 squared minus 2.75. They're both the same equation. They just look different from each other. So this one's been moved right 1.5 and down 2.75, meaning the vertex is at 1.5, comma, negative 2.75. Good times. We can go ahead and throw a dot down. It's not at integers, but oh well. Funny story, the name for the points where the integers cross, they're called lattice points. L-A-T-T-I-C-E. Not really important, just kind of fun to know in life. Alright, so we got the vertex there. We need the axis of symmetry, that's the vertical line, so it's actually kind of boring once you know the vertex. You just write x equals 1.5, and then you can feel proud of yourself as you're a vertical line that's not really there through. You got the y-intercept. Now the y-intercept is at 0, 5. Again, just plug in 0 into the equation. So you got patum. And then the symmetric point is on the other side of the axis of symmetry, but on the same y value. So here we're talking about 3, 5. So boing. And finally, zoom, zoom. You again can probably do better on your paper than I was able to do on the iPad. But hey, good times. You've got a parabola, you've got an axis of symmetry, you've got some points, you've got a vertex, which is like the important point. You've got these y-intercepts, which are kind of arbitrary points, but they're good starting points. And the symmetric point is a good symmetric point. Yeah, so we got good stuff. What we're really missing is the x-intercepts, and I promise you we will enjoy those soon. But we have our assignment for in class. Of course, don't need to do this until class starts. I hope you've had fun. Thank you for watching, and please let me know if you had any questions.